This is a super short mini lecture about fossils and how fossils are made. So what do you need to do to get to be a fossil? First, you gotta die. Then you gotta die somewhere where you're going to be buried before you decay or before scavengers tear you up. And where sediment will continue to pile up on top of you until you're pretty deep enough for lithification. And it really helps if you have hard parts like bones or a shell. If you don't have hard parts, then please die in a thick fluid like tar or pitch. Also, avoid dissolving in the fluids that are circulating around in the sediment pile while you are being turned into a rock, at least until you've had time to create a mold. And that's it. Now you become a fossil. Now you just have to get yourself back up to the surface where a paleontologist can find you. This, by the way, is a nautilus and a nautilus fossil. So two ideas that are really helpful to geologists in determining geologic history and the age of rocks. One is called faunal succession, which is just a really fancy way of saying that species that lived in a particular time period follow each other in a reliable and predictable order. So, in other words, we always see trilobites in really old rocks, we see fishes coming in later than that, we see amphibians coming in later, and mammals later, and hominids later still. Another really useful idea is this concept of index fossils. Index fossils are species that lived for a very short time over a very wide distance, and therefore they can be used to pinpoint that age in any rock in which they're found. So let me give you an example, not fossils. Somebody like Janis Joplin. Janis Joplin was a pop star, well renowned all over the world. If you find a poster from her concert, it might be from Stockholm or Austin or Rio, but you know it had to have been created sometime between 1968 and 1970. So Janis Joplin is, as it were, an index fossil for rock and roll. Let's talk about faunal succession again just briefly, because I want you to know about William Smith. William Smith was a surveyor and an engineer. He built roads all over England, and he had an opportunity, therefore, to see rocks all over England. He published the first geologic map of England in 1815, and he was the first to recognize the principle of faunal succession, that sedimentary beds can be identified by their fossils, something also that he published in 1815. He was the person who, in fact, identified many of the geologic eras and helped name them early on. And that's it. Those two very simple ideas, faunal succession and index fossils, can help you identify ages of rocks all over the world.